Okay, today we're going to test different chemical compounds for their conductivity using a conductivity probe and our SparkView software. So here's all of our solutions we're going to test. Some of them are ionic bonds, which will conduct electricity, and a few are covalent bonds, which will not conduct electricity or a small amount of electricity. That is going to be measured in microsiemens, which is the unit for electricity. Let's get our graph going. Let's rinse off the probe first in some water. Dry it off. Let's test our first solution, which is distilled water. I'm going to set our probe in there. And let's start our graph. You can see that the main reading is 0, and that's good. Distilled water has had all of the ions removed from it. Tap water will have some minerals for your diet and health, but distilled water's had everything removed, so this is kind of our negative control. So down here we're going to write down 0 Siemens for distilled water. And let's test our other solutions. After we've rinsed our probe, let's go on down to copper 2 sulfate. We can see that copper is part of the compound, so we're probably going to have some conductivity here with the metal. We should see that on the graph, and we do. We see it jump up there to about 300. If we look at our table, it's around 330 and increasing, but that's enough for us to get a baseline. So conductive solution, we know it has a metal called copper there. I'm going to rinse off our probe. And a polyatomic ion called sulfate. Let's try magnesium sulfate. Magnesium is another metal there in group 2 of the periodic table, the alkali earth metals. Let's stick our probe in and see what happens here. We know it has a metal, so probably going to have some conductivity, a little bit lower than copper sulfate at the same concentration, around 230. Magnesium sulfate is actually just Epsom salt, the kind you put in the bath for muscle aches. Let's rinse off our probe. Let's try sodium chloride, which is just regular table salt. NaCl. Sodium is an alkali metal in group 1, so we're probably going to see some conductivity. And we do. We see it jump way up to 800. NaCl is very conductive electricity. It's about 815, 813 if we look at our table. Let's rinse our solution. A few more to test here. Potassium iodide. Potassium is another alkali metal, iodine being the nonmetal. So this is a covalent solution, probably going to show electrical conductivity, and it does. Low, but still a lot higher than 0. It's moderately conductive at about 130 if we look at our graph. Let's test 2 more. Sugar, which you'll have to look up the formula for sugar, but sugar is a covalently bound compound with carbon, hydrogen, and oxygen in a 1:2:1 ratio. So this is a covalent solution, just regular sucrose, table sugar. So you're going to be wanting to look up sucrose when you look up the chemical formula. And let's see what happens here. Very, very low. Does not conduct electricity very well because it's sugar. It's covalently bound. There's no ions being formed. So we're down there at 7, very near the baseline. Let's check our last solution. Rinse off our probe. And we're going to test the IPA, which is the abbreviation for isopropyl alcohol. There's the formula, C3H80, O for oxygen. Also covalent. There's no metals in there. It is not ionic. Probably won't show any electricity, any conductivity, and it doesn't. Absolutely 0. So those are all of our conductivities. Please rewind the video if you need to see these numbers again. You need to fill in those numbers in your table when you get to the back. Oh, here's the back. Please make a bar graph or a line graph showing those different conductivities. Don't forget your labels and your titles. Explain why ionic compounds generate an electrical signal. And then we're going to fill in this table. Are these substances covalent or ionic? You can tell that given what elements are involved. Metals and nonmetals form a ionic bond, and two nonmetals form a covalent bond, and we're going to write the chemical formulas. You might have to look those up. I've provided some chemical formulas here. You need to definitely look up the sugar chemical formula. You're going to be looking up sucrose, and there is isopropyl alcohol. Otherwise, you can Google.